Hello everybody, here we are, first video of MidnightDevSec. Today we're going to look into how we're going to install MicroK8s. MicroK8s, it is an Ubuntu package that deploys into your server Kubernetes, a self-contained Kubernetes that you can manage, and you don't have to spend much time into playing with all the different components. It's perfect for starting, it's perfect for beginners that they want to start with Kubernetes and they want to learn with it. You can install it on your Ubuntu server, of course, and many other Linux distributions, but also you can install it on Windows and macOS. If you head to MicroK8s.io and you head to get started, you can see that there are multiple options for, again, Linux. You can install it into Ubuntu or any other distribution using Snap. You can also install it on Windows with a standard executable that you can download, and also you can install it on macOS with brew install. The instructions for installation is different, but the instructions for using MicroK8s are relatively similar to all those distributions. So what we're going to be looking into today is how to install MicroK8s. I have some notes here. How to set up Ubuntu to be ready for MicroK8s, how to install it, how to configure MicroK8s, which is a couple of things that we need to do based on instructions. We're going to play with some of the add-ons and we're going to see what the add-ons are for, and then we're going to deploy a test deployment on this Kubernetes cluster that we have on our local host. For doing that, we have a VM, an Ubuntu VM on the bottom right of the VS Code window that we can play with. So let's go ahead and see what we have on our files. We have a setup script that we can either run automatically, or we can take the commands one by one and see what the command is doing. We have the install MicroK8s script that is taken from the instructions that MicroK8s has, but also has some additional commands for some additional tools that we might need and some additional configuration. And then we have a deploy test.yaml, which is a Kubernetes manifest, a very simple Nginx server exposed on a specific port 80, and we can see how we can use that, how we can amend it, and see how fast it is to do all the changes, but also how easy it is to scale that into a bigger application. So let's start with setting up our Ubuntu server. So first we're going to become root and update and upgrade the system. We have 5 packages that we could have upgraded, but we can go ahead with it and not update them because we don't specifically need them. Then we can go and install our curl, wget, vim, and nettools. Curl and wget, we're gonna need them for some of the future videos, but vim is something that we're gonna need for this video, and nettools is something that we're also going to need for this video. Okay, good stuff. Nice. Then we're going to install snapd, which is the package manager that we need to take care of installing MicroK8s. So snapd is very similar to apt or yum, but it's significantly easier to get packages into the repositories. Nice. So now we have snapd, so we can do snap and third. So updating the Ubuntu server and installing some of the prerequisite packages is now done, so we can tick that off. Let's look into installing MicroK8s. Again, MicroK8s it's a single package that has Kubernetes, that is Kubernetes from Ubuntu Canonical, and you don't need to install all the different components that Kubernetes has as an application on a cluster. It's a self-contained application, and we can look into what exactly it has and how it runs in one of the future videos. So for now, let's install MicroK8s with a snap command as per the instructions. What might happen is you try to install it, first time it might fail, you run it again, it is almost guaranteed that it is going to be installed. And we can see it downloaded some core packages, some packages from the core repo. Now it's going to download and install MicroK8s. You can see on the terminal it's from channel 131, and this is the version of Kubernetes it's going to be using, so it is 131.2. Excellent, so now MicroK8s is installed. The next is we're going to install kubectl. kubectl is a tool to manage Kubernetes, and we can look into it further down on this video. Excellent, so kubectl is installed as well. Now, as per the instructions again, we're going to modify our current user and include our current user into the MicroK8s user group in Linux, and that's a very specific command for Linux. For any other operating system, you can look into the instructions on the website. Next, we're going to create a .kube folder on our home directory. Excellent, so we can look into if the folder exists. And why the .kube folder is used is because Kubernetes, through the kubectl, actually the kubectl CLI, to connect to Kubernetes is looking into one of two things. Either is looking for an environment variable called kubeconfig with uppercase letters, single word, or is looking for a specific file under the .kube directory. And the file, we will see later how we can create it, but you can also see it on the script instructions. And that's the only two ways that the kubectl command can connect to Kubernetes. And we can explore a little bit of it later as we're going to be using the kubectl command. Then we're gonna change the permissions of this directory to our current user. And before we go to the next command, let's see what MicroK8s command has. So if we do MicroK8s, we can see it's a very simple output that we can get a status, for example, and we can see a bunch of things. If this command fails to run for any reason and asks you to run the user mode as earlier, then you might need to log out and log back in on this VM for your user to get the right permissions. But again, we can see MicroK8s status. Okay, so we can see it's running on the current host, and we can see some of the add-ons that are enabled, and we can look onto what these add-ons are and some of the add-ons that are disabled. And for example, if we run MicroK8s again, we can get a version which is 131.2, and again, this is the version of Kubernetes installed in MicroK8s. And we can also look into the config. So that's the MicroK8s config, which we can look into how we can use kubectl with this config to connect to MicroK8s and run standard Kubernetes commands through kubectl. So we've spoken about add-ons, and what MicroK8s does is to make it very user-friendly and easy for every user to use it. It has encapsulated some either community repositories that you can enable, or some repositories that it comes with, and they're maintained by Canonical, that contain some add-ons. And if we look again into the website, we can see, so let's go back, so we can go under features, and we can go to add-ons, and we can check all available add-ons. So if you would install Kubernetes into a cluster, a range of VMs, or even physical bare metal cluster, you might want to install things like Metal Load Balancer. Metal LB, which is a metal load balancer between all the different clusters of MicroK8s. Or you might want to install an ingress controller, or you might want to install a certificate manager. You can do that with standard Kubernetes installation. If you would have to go into Helm or Kubernetes manifests, download them, store them somewhere and install them. For MicroK8s, to make that easier, you can just use an add-on that enables these features for you. And you don't have to worry about the underlying installation of these packages. Even though you can configure some of them and some options, the whole installation is taken care for. What we can do, we can go and install the ingress and see how the process looks like. So it's very simple. This add-on adds an Nginx ingress controller for MicroK8s, and you can enable it by running this command. Okay, the URL was a little bit of MicroK8s enable ingress, and we can see that installs a range of Kubernetes resources, which will be a great segue to see how we can see these resources and how we can relay with the kubectl command. So we can see that it's trying to enable ingress, and then it installed a bunch of resources into Kubernetes, the MicroK8s Kubernetes that we have, and then ingress is enabled. So let's see how we can actually play with the kubectl command. So if we were to do kubectl get nodes, for example, that will fail because, as it says, it cannot connect to a Kubernetes cluster. There is no configuration to do that. And why there is no configuration? Because if we were to look into the environment variables and we grab for kubeconfig, if we write it correctly, then there is no kubeconfig setup. We can also do echo kubeconfig. There is nothing there. If we were to look into our home directory and on the kube folder, kubectl expects a file called config in there. And this is the second way that kubectl can connect to a given Kubernetes, and there is no file there called kube. So what we need to do is we need to use MicroK8s as per the instructions above. We need to use MicroK8s config and export that into the kubectl expected path. So if we run the command MicroK8s config, we can see as earlier we have a massive YAML file, which we can look into it momentarily. So let's export that into kube/config, and now we can test again the kubectl command and see if we can get nodes. And of course we can now see that we can get one node named Ubuntu, which is ready, is 7 minutes old, and the version of Kubernetes is 132. As you've seen earlier, the kubectl config is a YAML file, and this is what kubectl is using to connect to the cluster. So let's have a quick look without too much confusion into the YAML file. So the YAML file splits into two sections. One of the section is the cluster information that we can see up here, and the second section is the user information. Of course, we have some other attributes within, which is the context and the kind and preferences, which are important, but for the sake of this video, we can simply ignore them. So kubectl will try to use either the environment variable, as we said, or the file. Looking into the file, it will try to identify a cluster, and the cluster will have a name again, and it will have an IP, and it will have a certificate, a CA, to authenticate with and to establish a secure connection. So this IP, if is the IP that MicroK8s exposes the Kubernetes API, and we can look into what the Kubernetes API is in one of the next videos. It exposes the Kubernetes API so kubectl can connect to. You can, if you want to access your VM from a different host, replace this IP with the IP of your VM, and then you can get all the config file and put it onto your other host, onto your laptop. And when you run kubectl on your laptop, that you have already this config file in your laptop in the correct directory, kubectl will try to reach this IP, will use the CA, and then will try to authenticate with the user that we have below. So as we said, there is a user, the current user is admin, which is also the default user for every Kubernetes installation, regardless of how you get it. And we have a certificate key and a certificate for this user. And then we can see other bits and pieces. For example, we have the context, which is set up, which is the current context is what we have in the config file. And we have some preferences and some other minor details. So what we've done so far is we have installed MicroK8s, we have set up Ubuntu, we have installed MicroK8s, we can configure MicroK8s, and of course kubectl, and we have enabled an add-on. Now let's see what this add-on is, and let's explore a little bit more the Kubernetes environment that we have configured. Of course, after drinking a little bit of coffee. So, kubectl, we can do version, and we get a kubectl version. We can see 3 different numbers. One is the client version, which is the actual kubectl version, which is the client application. Then we have customized version, which we can look into one of the next videos. And we have the server version. It's the server that kubectl is trying to connect it and has already been connected. So we can see all these numbers matching, which is perfect. Ideally, you don't want to stay too far between this client and server version. Also, for the sake of convenience, let's create an alias, which is k equals kubectl. This alias is temporary, but you can export it into your bash.rc or zshrc or any of the other shell configuration you might have. So now we can do k get nodes. So we can see again our nodes. We can do dash or wide, and we can see a few more information. So we can see, for example, the IP of the node, and we can see the operating system this node is running, and we can see the kernel version, what container runtime is running, etc. We can also look into what is currently deployed in Kubernetes. So if you're coming from a Docker environment, you probably think of network and volumes and containers, and images. So Kubernetes is not much different. So what we have in Kubernetes, we have pods, which pods is very similar to Docker containers, but we have multiple containers inside, and we can look into it later on. So if we get pods, you will see that there is no pods, no resources named pods found on the default namespace. We can add -a for all namespaces. What a namespace in Kubernetes is a separation in between the different pods or resources you might have, and it has a complete isolation, which we can also look into it in one of the future videos. So we can see now namespace Ingress has one pod called Ingress and Nginx Ingress MicroK8s controller. Namespace kubectl has 3 pods, which is the Calico. Calico is one of the networking plugins for Kubernetes, so you can do all the underlying networking. So we can see these pods are running, and we can see 1 out of 1 is ready, and we can see the age and how many times this pod might have restarted. And if that's a little bit confusing for now, don't worry, we can look into it in one of the next videos to understand a bit better what the Kubernetes resources are, and maybe make some connection to either VM or Docker for some of you that are coming from this environment. So we can see that we have an Ingress, which we installed it earlier by using the MicroK8s enable Ingress commands, and we got to have a range of things installed. What else we can see is that this is a pod, so therefore there is a Docker container of some sort running underneath. So if we do kubectl describe pods, and now we can see all the pods here that we have inside this host, and it describes them by giving us a YAML configuration out. So let's go back again and get the pods. Now we see we have the Ingress pod, so we have the Nginx pod inside the Ingress namespace. So if we try to describe that, we can take the name. And then we give the -n for namespace. So now we've been describing the pod ingress, Nginx ingress, and we can see briefly what's inside there. So inside this pod, we have a container ID. We have an image, which is the Nginx ingress controller. We have a range of ports and host ports. We have arguments very similar to how you would have in a Docker compose or a Docker run command, perhaps. Then a bit further down, we have events, which happens that here there are 0 events. And the reason I wanted to show you this is because next step is the deployment of an Nginx container, Nginx pod, as it's named in Kubernetes world. So you can see some of the relevance that we have from this description. So let's go and test a deployment in Kubernetes. So deployments in Kubernetes happen multiple ways. The very primitive and basic way is by writing a YAML file that contains resources, Kubernetes known resources, and you can separate those resources with a YAML header, which is the 3 hyphens. So on this file, we can have products, we can have multiple resources again. The first resource we have is a deployment, and as we can see, deployment enables declarative updates for pods and replica sets, and we can look into what replica sets are in a different video. And it happened that my VS Code plugin for Kubernetes, it just shows some of the options that we have. And then we have a service on the same file, which is a way that we would expose any given pod into some networking configuration, such as a cluster IP or a node IP, and we can look into what this is again, because it might be a bit confusing at this point. So how do we deploy this Kubernetes application into Kubernetes? We're using kubectl. So let's take all this code, go into our banana user, and we can vim a test_deployment.yaml, and it is not necessarily important to be YAML file type, but it's better if we name it that. Now we can set paste or vim, and we can paste that in, so we can see it looks perfect. It looks as earlier. And of course, if you're not comfortable using vim, you can use Nano or Emacs, any of the other editors that you'd like to. We can save that, and we can use kubectl apply -f for file, and then we can give it the file that we created, which is a test file. So we can see it took a moment, it thought about it, and then it told us that a deployment and a service has been now created on the cluster. What happened is kubectl took the file to do some validation, and then look into it and said, we have a deployment resource and we have a service resource. It converted it into JSON, sent it to the Kubernetes API, which is encapsulated inside the MicroK8s deployment. The Kubernetes API has taken now this JSON with all the different details, as we have it in our YAML, and it has created the relevant resources. And we can look into how this process works in one of the next videos. But all we care about now is that we have one deployment and one service deployed in Kubernetes. you would wonder what does that do and how we can see what we deployed. Once again, kubectl get deployment, and we can see we have an Nginx deployment. One is ready, and it's about 57 seconds old, and we can do kubectl get service. And we can see two. The Kubernetes one is the default that gets installed as part of the Kubernetes installation. And we can also see our Nginx service. And you can see the names are corresponding to the names that we had on our YAML. And if we go to describe, so if we get the pods again, sorry, if we get the deployment again, so we can do now kubectl describe deployment Nginx deployment, and we can get a reasonably big output, which if you look into it, it looks very, very similar to what we have on our YAML file above. So we have the name, we have the namespace, which is always default. If you do not specify, then we have some labels and annotations. We have what's called the replicas. It's how many replications of this Nginx container, Nginx pod we have, and is configurable, as you can see on the YAML above. We have some strategy type, which we can look into it later. And then we have our pod template, which it matches almost identically to what we have above. So we have the image, which is a Docker Hub image, Nginx latest, we have a port exposed. And further down, we have some other little details of the deployment, which we can explore them a bit later. And we have events, which is probably one of the most important things in case something doesn't go well. So we can see that this was deployed and then it was scaled to 1. So we have 1 pod. This 1 means that we have 1 pod. So if we now do kubectl get pods, we can see that indeed we have 1 pod that has very known name, Nginx-deployment, and then it has a randomly generated identifier. We can see it's 3 minutes old, so we can do kubectl describe pods, and we can grab this name. And now we can see more details of what this pod has. So of course we can see all the bits that we had on the deployment, such as name, namespace. We can see which node is deployed on and the IP of the node. We can see some of the labels and annotations that have been attached to this pod. We can see an internal IP. We can see where this Docker image has been taken from, specifically the SHA, the URL. We can see the networking information. And if we scroll a bit further down, we can see history of events that happened when this pod was created. So we can see it was assigned to the server, a Kubernetes server. Then the image was pulled, successfully was pulled, and it was created as a container, and the container was started. And we can see every single timestamp of this and the specific details and how that happened. So now we have a Kubernetes pod, which is technically a Kubernetes container running as a deployment. So let's see about the service. So if we do kubectl get service, we have an Nginx service. It's a cluster IP. So that means on the whole cluster, there is a single IP exposed for this specific host, for this specific service. And we can look into the different types of services, but for now, all we care is what if we ping this IP? So we can ping 10.152.183.166, and we cannot ping it. But what if we curl this IP? Okay, that seems to got stuck. So let's do some troubleshooting. So if we do if config, we can see that there are some new interfaces called Kali, which is from the Calico network. Okay, so let's exit the host and oops. Exit the host and enter again. And let's curl that. Still get service. Okay, curl 10.152.183.166. Okay, there we are. So we could curl that, we could ping it 10.152.183.166. Ping is not going to work, but curl will do. And when we curl it, we get a standard Nginx page, which is the service has a cluster IP. We're hitting this cluster IP, and then we're going directly into the pod that we deployed through the deployments as we had. We can see also if we do kubectl exec -it, we find the specific command. So kubectl exec in pod. All right, there you are. So Kubernetes documentation. Yada yada, perfect. So let's take this command and back here, let's get our pods so we can have the name. And now taking this, going back, replacing the cell demo. Excellent, so now we are inside the pods. Nginx, for those that who know, has a HTML directory, so we can cd user stir Nginx HTML, and in there we have an index.html. So if we cut that, it looks exactly like the index.html that we got earlier. So if we were to say move that into backup, and if we were to echo banana into index.html, so now we have single word banana in there. If we control D to exit this pod, and now we curl the Nginx pod again, we can see that is instant. The new index HTML has taken place, and of course it's not the right way to do it because this is not persistent. If we were to kill this pod, or this pod is to be killed and a new one will be started again, then we will lose all this data. So in one of the next videos we can look into how we can have persistent storage between the deployments and the pods. So we have now finished everything, and let's look into it again. We have set up Ubuntu, we installed all the necessary packages, and we did an update as well by using the instructions and the commands inside the setup.sh. We have installed MicroK8s, and we have done all the configuration for MicroK8s, and we looked a little bit into the add-ons, we looked a bit into how kubectl is working, and we looked into what we can do with kubectl and some of the options. And finally, we deployed an example deployment in Kubernetes, and we looked into some of the options that we have for networking, but also how we can manipulate files inside this container, inside this pod that has been created as a resource, and how we can actually access it through the network. We can look into Kubernetes resources and how to work with them more effectively and efficiently in some of the next videos. So I would recommend you subscribe and you hit the notification button so you can be up to date with any of the videos that are coming up. What we're looking to do is some of the next videos, we're going to dive deeper into the kubectl commands. We're going to dive deeper into the Kubernetes manifests, the YAMLs that we looked into today, see how we can structure them better. We can look into some templating options and how we can make them much more versatile and programmatically approaching them with a package called Helm, which is a templating approach into Kubernetes manifests. And we can look into how to deploy a standard application with having a server, like an Nginx server, having a storage to store data, and maybe deploy a little website and see how we can access this even from the internet in a publicly served IP or a publicly served domain. So that's for today. Thank you so much for joining. I'll see you in the next video.